Video presented to you by Unique to Billions e-learning. Please subscribe it and press the bell icon. Mean of group data. In this video, we are going to study how to calculate mean of group data. There are three methods to calculate mean of group data. They are direct method, assumed mean method, and step deviation method. In this video, we will cover all the three methods. First, mean of group data by direct method. We already studied for an ungrouped data, if x1, x2, x3, etc. up to xn are n observations and respective frequencies are f1, f2, f3 to fn. Then we know mean x bar is equal to sum of fi xi divided by sum of fi. You can learn more about this along with examples in videos for class 9 mathematics. We have also studied that if data is large and widely spread, we need to group it to represent and conduct meaningful studies. Now, our aim in this video is to find mean of this group data. To calculate the mean of group data, we need to get an xi from the data. For that, we assume that frequency of each class is distributed equally in the class or is centered around the midpoint. This helps us to assume that the midpoint or the class mark of the class will represent the observations falling in the class and is taken as xi. Thus, midpoint or class mark is obtained by the equation upper class limit plus lower class limit divided by 2. So, we got xi's and we know fi's. Therefore, by using the equation x bar is equal to sum of fi xi divided by sum of fi, we can calculate the mean of group data. This method of finding mean of grouped frequency is called direct method. Let us see with an example. Consider height in centimeter of students in a class of 60 students. Calculate the mean height in centimeter. It is given that height of students in centimeter in groups, number of students in each group is given, which is fi. Now, we need to find the class mark, which is xi. So, I need to draw columns for class mark and fi xi. We know the equation for class mark xi is upper class limit, that is 110 plus lower class limit 100 divided by 2. that is equal to 105. In the similar way, we can calculate the class mark for each class, that is 120 plus 110 divided by 2 is equal to 115. 130 plus 120 divided by 2 is equal to 125. 140 plus 130 divided by 2 is equal to 135, like that. Now we need to calculate Fi Xi. So here Xi is 105, Fi is 2. So it will be 210. 4 into 115 is equal to 460. 10 into 125 is 1250. 26 into 135 is equal to 3510. 13 into 145 is equal to 1885. 5 into 155 is equal to 775. We know the equation for x bar, the mean, is equal to sum of Fi Xi divided by sum of Fi. Sum of Fi Xi is the sum of all these values, that we can calculate as 8090. So I can write 8090 divided by sum of Fi. Sum of Fi is already given, it is 60. So the answer is 8090 divided by 60, that is equal to 134.83 centimeter. Therefore, mean of group data by direct method in this example is 134.83 centimeter. Now we are going to understand the second method to calculate the mean of group data, which is assumed mean method. In the previous example, we saw that calculation of products and numerical values become more tedious and time consuming. If numerical values of Xi and Fi are large, finding the product Fi Xi becomes more tedious and time consuming. In assumed mean method, these calculations are reduced. This can be done by changing the values of Xi to a smaller value. The idea here is to subtract a fixed number from each of these Xi's. In this method, first we need to calculate the class marks, which are Xi's. From this, we need to select one among these Xi's as assumed mean. I named it here as A. Think our aim here is to make Xi's as small as possible. We are going to subtract the assumed mean from each of these Xi's. So if we need to make these Xi's small, we need to take a middle value. So it is always better to select that value of Xi which lies at the center as A. Then we need to find the difference xi minus A. That is the deviation, we call it as di. So di is equal to xi minus A. The next step is to calculate fi di. This will help us to find the mean of deviation, that is d bar is equal to sum of fi di divided by sum of fi. This equation gives only the mean of deviations. Here our aim is to calculate the mean of observations x bar. So we need to find a relation between x bar and d bar. We know mean of deviations d bar is equal to sum of fi di divided by sum of fi. Also we know di is equal to xi minus A. Substituting that in this equation, we will get sum of fi xi minus A divided by sum of fi. That can be written as sum of fi xi minus sum of fi A divided by sum of fi. Rewriting it like this, sum of fi xi divided by sum of fi minus sum of fi A divided by sum of fi. We know A is considered as a constant which is assumed mean here. So I can cut it sum of fi. What is sum of fi xi divided by sum of fi? That is the mean of observations x bar. So x bar minus A. So I got d bar, that is the mean of deviations, is equal to x bar minus A, or I can write the mean of observations x bar is equal to mean of deviations d bar plus A. That is, I got the equation for the mean of observations x bar, that is equal to A, the assumed mean, plus mean of deviations. So if we know A, the assumed mean, and mean of deviations, we can easily calculate the mean of observations by just adding them. Now we can calculate the mean of group data by assumed mean method in the previous example. That is, height of students in centimeter for a class of 60 students is given. We need to calculate the mean of this group data by assumed mean method. First, we need to calculate the class mark that we already calculated in the previous case. The class marks are 105, 115, 125, 135, 145 and 155. Now we need to take A, the assumed mean. In this data we can see that there is no data placed at exact center. There are two data that can come at the center. They are 125 and 135. I can take any of these, there is no problem. We will see it later. For doing this, I am now taking 125 as A. Now we got A. The next step is to calculate DI, which is Xi minus A. In this case, it is Xi minus 125. That is, I need one more column for DI, which is equal to Xi minus 125. So in the first case, DI is equal to 105 minus 125, that is equal to minus 20. For this class, it is 115 minus 125 is equal to minus 10. Like that, I can write 125 minus 125 is equal to 0. 135 minus 125 is equal to 10. 145 minus 125 is equal to 20, and 155 minus 125 is equal to 30. Next step is to calculate Fi DI, to calculate the mean of deviation. So the numbers are become much smaller. So we can easily calculate the product Fi DI here. That is 2 into minus 20 is equal to minus 40. 4 into minus 10 is equal to minus 40. 10 into 0, 0. 26 into 10, 260. 13 into 20 is equal to 260, and 5 into 30 is equal to 150. We need to find the sum of Fi DI, that is equal to 590. We know mean of deviations D bar is equal to sum of Fi DI divided by sum of Fi. From the table we can easily see sum of Fi DI is 590 and sum of Fi is 60. That is equal to 9.83. We know the relation for the mean of observed data x bar is equal to assumed mean plus mean of deviations. We know assumed mean is 125. Mean of deviations we calculated it as 9.83. So mean of observed data is equal to 134.83 centimeter. We can see that mean of grouped data calculated in this case by assumed mean method is 134.83, which is same as the mean we calculated by the direct method for this same case. Now we need to see whether my choice of A affects the mean. Let us do this same example by taking A is equal to 135. I need to redo this much part again. For that, let us draw columns. Here, DI is equal to Xi minus 135, and I have to find Fi DI. So you can calculate here 105 minus 135 is equal to minus 30. 115 minus 135 is equal to minus 20. 125 minus 135 is equal to minus 10. 135 minus 135 is equal to 0. 145 minus 135 is equal to 10. 155 minus 135 is equal to 20. I need to calculate Fi di. Minus 30 into 2 minus 60, minus 20 into 4 minus 80, minus 10 into 10, that is equal to minus 100. 26 into 0, 0. 13 into 10, 130. 5 into 20, 100. The sum is minus 10. The mean of deviations in this case d bar is equal to sum of Fi di divided by sum of Fi, and I know sum of Fi di in this case is equal to minus 10 divided by sum of Fi is 60. That is equal to minus 0.17. I know x bar is equal to a plus d bar. In this case, a is equal to 135 and d is equal to minus 0.17. Therefore, x bar is equal to 135 minus 0.17, that is equal to 134.83 centimeter. This is same as I got here. So, the selection of A is independent of the value of mean. Now, we are going to calculate mean of group data by step deviation method. In some cases, the value of di itself is a bigger number. This can be reduced by dividing with a suitable divisor. We call it as h. If class weights or class size are equal, better choice of h is class width. Why? We can see in the previous example, look at the class width is same here, that is 10. Di here is a multiple of 10. So, if I divide with the class width, I will get a smaller integer, which is more easy to multiply. That is, I am denoting another ui, that is equal to di divided by h. I know di is xi minus a, therefore ui can also be written as xi minus a divided by h, where di is the deviation, a is the assumed mean, and h is a suitable divisor, commonly the class width if class size is equal. We know mean of ui, that is u bar, is equal to sum of fi ui divided by sum of fi. We need to find the relation between x bar and u bar. For this, we already know ui is equal to xi minus a divided by h. Substituting here, I can get u bar is equal to sum of fi into xi minus a divided by h divided by sum of fi. H is a suitable divisor, is a constant, I can take it out. Therefore, u bar is equal to 1 by h into sum of fi into xi minus a divided by sum of fi. That is equal to 1 by h into sum of fi xi minus sum of fi a divided by sum of fi. I can write u bar is equal to 1 by h into sum of fi xi divided by sum of fi minus sum of fi a divided by sum of fi. Since a is constant, I can cut it out, sum of fi. Therefore, u bar is equal to 1 by h into sum of fi xi divided by sum of fi is x bar minus a. This can be rewritten as u bar into h is equal to x bar minus a. So, I can write it as x bar is equal to a plus h u bar. So, I got a relation between mean of observations x bar with u bar. Let us calculate mean of group data for the previous example. We already calculated the values of class mark xi and di with a is equal to 125 in the previous example. They are as written here. Now, we need to calculate ui. For that, I need to take an h. Here, the class width is equal, therefore it is suitable to take the class width as h. The class width here is 10, so I am going to take h as 10. Therefore, ui is equal to di by h, that is equal to di divided by 10. I need to calculate ui for each di. The first case, minus 20 by 10, that is equal to minus 2, minus 10 by 10, that is equal to minus 1, 0 by 10 is equal to 0, 10 by 10 is equal to 1, 20 by 10 is equal to 2, and 30 by 10 is equal to 3. The next step is to find fi ui. So, the numbers are very small, so I can easily multiply it. 2 into minus 2, minus 4, 4 into minus 1, minus 4, 10 into 0, 0, 26 into 1, 26, 13 into 2, 26, and 5 into 3, 15. The sum is 59. We know u bar is equal to sum of fi ui divided by sum of fi. Sum of fi ui here is 59, sum of fi is 60. That is equal to 0.983. We know the relation x bar is equal to a plus h u bar. Therefore, x bar is equal to a. We know a is 125. H is 10 into 0.983. That is equal to 125 plus 9.83. That is again 134.83 centimeter. I got the same answer that I got in the previous two methods. That is, in all the methods, the answer is same. That is 134.83 centimeter. So, which method to be used? That depends upon the numerical values of xi and fi. If xi and fi are small, use direct method. If xi and fi are not small, you can use either assumed mean method or step deviation method. Remember, if class width are equal, then in step deviation method you can take h as the class width. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.